A patrol car is parked 50 feet from a long warehouse. The revolving light on top of the car turns, that's what it should be, turns at a rate of 300 revolutions per minute. How fast is the light beam moving along the wall when the beam makes an angle of 30 degrees? So of course, you know, this here represents the light, so of course it's revolving around. So as it comes down this wall, at what rate of change is that angle changing as it does this? Okay, of course they already have, like for instance, this side here labeled as X, so we'll know what variable to use concerning that. Now on your given information, we have d theta dt. That's going to be given because that's going to be the 30 revolutions per minute, okay? The revolving light on top of the car turns at a rate of 30 revolutions per minute, so that's going to be this angle here. Now, that's 30 revolutions per minute. Okay, what you're going to need to do here is actually change this over to be radians per minute instead of revolutions per minute. And all that you would have to do to change that would be to multiply the 30 times 2 pi, because if you remember, there's 2 pi radians in one rotation. So of course, like 1 revolution is the same as 2 pi radians, like, you know, just around a circle, okay? So if you've got 30 revolutions, then that means you need to do 30 times the 2 pi radians. So what we're going to end up using when we're substituting our values in is going to be 60 pi. And that's now going to be in radians per minute. Okay. Let's see. Of course, the 50 is actually already on the picture. But again, this is a number that is not going to change. As this light beam goes around, the angle changes, the movement down the wall. Because, I mean, you know, in a few minutes, this light will end up shining way down here. But the distance from the wall to the car is not going to change, okay? So we're actually going to end up putting the 50 in as we set up our equation. All right, so what we're trying to find, remember, is the rate in which it moves down the wall. Since they've already labeled this as x, then that means we're going to be finding dx dt, that rate. Okay, so we're dealing with trig again here because we are involved with an angle, okay? So from this angle, of course, we're going to incorporate this side, so that's the adjacent side, and of course over here is the rate in which we're trying to find. So this is going to be tangent again, because from this angle, x is going to be the opposite and 50 is going to be the adjacent. So I would have tangent theta is equal to x over 50. And again, I'm allowed to go ahead and put the 50 in before I do the differentiation because that value's not changing. That's going to stay. All right, so the derivative of tangent is secant squared. And then you'd have d theta dt. Okay, just like a while ago I had the 1/60th, this would just treat this as 1/50th x. So that would be 1/50th dx dt. Okay, of course dx dt is what I'm trying to find. I do have d theta dt given to me. Now, a while ago I had to come up with a value to replace all of secant theta with. I actually don't have to do that here. I could, but what I'm going to do instead this time is I actually have an exact value for 30, and I meant to go back and write that down. That's actually part of your given information is, you know, you're wanting to know exactly what this rate is when that angle reaches exactly 30 degrees. So that was another piece of given information. Okay, so I would have secant squared of 30 degrees. Of course, this is going to be multiplied times the 60 pi is equal to 1/50th dx dt. Okay, now we need to come up with a value for secant of 30 degrees. Okay, so first of all, just think in terms of cosine. And we know that cosine 30 degrees is equal to square root 3 over 2. So that would mean secant would have to be the reciprocal. Of course, whatever I substitute in, I need to square. So I would have 2 over square root 3 squared. Of course, times the 60 pi is equal to 1/50th dx dt. Okay. Let's see. Let's go ahead. I tell you what, just so we're kind of putting all this in the calculator at one time, before I even bother to go put all of this in, let's go ahead, and if I were to get dx dt by itself, that would mean that I need to multiply both sides by 50. So I'm going to go ahead and just put the times 50 here, and we'll just mark that out. That'll be gone. All right, so dx dt. So I could go ahead and do the 50 times the 60, so that's going to give me 3,000 pi. Of course, I've got to square the fraction, so that would be times 4 over 3. Okay, so that's going to actually end up giving me 4,000 pi. And that would be in feet per minute. Now I know, of course, you're talking about the distance, the rate down that wall. So I know it's feet because the 50, the distance from the car to the wall was given to me in feet. So that's how I know to go with feet. And of course, I know to go per minute because going back, it told you that the light was rotating at a rate of 30 revolutions per minute. So your answer to that would be feet per minute. Of course, the answer, in the back may actually kind of have that rounded off, which is fine if they do.